Okay, folks, just wanted to show you really quickly how to graph a tangent. I assumed incorrectly that all you needed was some asymptotes and a coordinate, but then that wouldn't show increasing or decreasing. So wanted to show that really quickly and how you do that within the Aleks system. So you'll notice here that I have an equation. This is exactly the same as it is over on the Aleks half of the screen. I cannot use a laser on the Aleks half of the screen, so just understand that I can point to it, but you won't really be able to see anything. So we have a period that is pi over b, so that's going to be pi over 5. Phase shift here is going to be c over b, so that's pi over 4 over 5 over 1, which is going to become pi over 20. I don't deal at all with the negative until I decide what direction it tells me to go, and so that minus sign just tells me to go to the right. All right, so as shown in class, I really like to deal with the period before I deal with any shifting. And so if I were to deal with the period on this particular example, I've already marked out the ending of my pre-shift. So I'm not dealing here with a shift yet. My ending is going to be at pi over 5. Half of pi over 5 is going to be pi over 10. And if you don't understand how I did that, just think of 1/2 of 1/5 is equal to 1/10. Half of pi over 10 is going to be pi over 20. And then I'm just going to count. So this is 1/20th. This is 2/20ths, which reduces. Then I have 3/20ths. And then after 3/20ths is 4/20ths. And that actually works out just right. 4/20ths reduces to 1/5. After that would be 5/20ths, which is going to be pi over 4, which we may need in a minute, but that's past my ending value there. So with our tangent graph, remember that the middle is where my asymptote is, and I'm just going to draw this really lightly because I still have to shift everything. And then from there, this is an increasing graph. So we're going to go uphill towards that asymptote, and then on the other side of the asymptote, we're going to go all the way up to that pi over 5 there on the x-axis. Now, when we shift, let me switch colors. When we shift, we're going to shift everything to the right a distance of pi over 20. So that means that this guy is going to go to the right a distance of pi over 20. So it's going to be my new x-intercept. My asymptote here is going to go to the right a distance of pi over 20. So it's going to be my final asymptote. And then that last coordinate is going to go to the right a distance of pi over 20. And so on paper, it's not difficult to show that it's increasing and decreasing. But then how do you do that on Aleks? So what I would recommend is you are going to choose one of two things. Either choose the very left coordinate, x-intercept, x value that's marked on your graph, or choose the very right one, either the very left or the very right. You're going to take that x value, whichever one you decide on, you're going to substitute it for x since it's your x value, and then you're just simply going to do the math on this. All right, so with that said then, let's go ahead and do this. Eeny, meeny, miny, mo, I'm going to choose pi over 5 because when I choose pi over 5 to go in here, my 5s are going to cancel and that's going to turn out really nicely. All right, so if we have tangent of 5 times pi over 5 minus pi over 4, so this is going to be tangent of pi minus pi over 4. Now you do have to know how to add and subtract fractions in Math 111. So my brain says I'm going to make this into a 4/4 because 4/4 is equal to 1. So 4/4 minus 1/4 is equal to 3/4. So tangent of 3 pi over 4 is what we're looking for. So then my brain is going to go to the unit circle. And I'm going to ask myself, where is tangent at this position on the unit circle? And remember that tangent is my sine over my cosine, or my y value over my x value. So it's going to be root 2 over 2 over root 2 over 2, and one of those is going to be negative. The x value is going to be negative. So this is going to equal a -1. All right, well, that means that, again, when I plug in a pi over 5, my y value there is going to be a -1. Now, the nice thing is you do have to enter in more than one coordinate, I believe. And so if you just simply go to the other side of that, the other side is going to be like that, not a mirror image, but rotated around the origin kind of thing, where if this one is right one, down one, this one's going to be left one, up one, that kind of a concept. All right, so let's show what that looks like then over here. All right, so now let's go over to Aleks and let's plot our graph here. To draw the graph, it says plot 2 consecutive asymptotes and at least 3 points between those 2 asymptotes, and then click on the graph icon. Okay, so first of all, let's get our asymptotes. We found that we have one here at 3 pi over 20. Let's put that one in. All right, and then notice that our period is pi over 5, and on your Aleks graph, you'll notice that pi over 5 is worth 4 blocks on the grid. And so all I have to do is either go right or left 4 blocks to get another asymptote there. All right, so now I've got my 2 asymptotes. And then the other thing is it says to plot 3 coordinates. So I'm going to change to my pencil. My x-intercept is at pi over 20. We already said that if we were to go from the asymptote left 1, we could go up 1. So that's going to be at pi over 10. Let's go up 1. And then the same thing idea is if we were to go from this, from this here x-intercept, we were going to go left 1, down 1, just like over here it was left 1, down 1. Okay, so from the pi over 20 then, we can go left 1 and down 1. We'll put a coordinate there, and let's go ahead then and we can draw. We will check our work. And this says that we got it correct. So that's probably the easiest way to graph on the tangent graphs.